Assalamu alaikum everyone. I am Musa Muhammad Murshid Al-Kahlani from Manufacturing Engineering faculty. And today I would like to present my final year project, which is preparation and characterization of transesterified West coca oil as processing oil for sustainable rubber compound. And here is a table of contents: introduction, methodology, result, and discussion, conclusion, references. First of all, in FKP1, previously I have been explained about introduction, and today in FKP2 I will explain about problem statement and objectives. However, the most of existing processing oil to produce the rubber compound is the high aromatic oils or paraffinic oil. The main issue is that those oils have a high content of potential carcinogenic containing polycyclic aromatic hydrocarbons, and from 1st January 2010 was prohibited to use and selling polycyclic aromatic hydrocarbons by the Council of the European Communities. Moreover, there is no available previous study using treated West coca oil or transesterified West coca oil. And secondly, here is the objectives of my final year project. First one, to modify West coca oil onto usable processing oil for rubber compound using transesterification method. Secondly, to evaluate the potential of transesterified West coca oil to be used as processing oil for natural rubber based compound. And lastly, to test the mechanical and physical performance of natural rubber based performing various experimental. Secondly, we have the methodology part. In methodology part, we have the overview and flow chart of the methodology of this project, which explained how I shared all objectives step by step. And on this part, I will try to explain transesterification process. Firstly, collecting 1 liter of West coca oil from Yathrib restaurant, 1 liter. And Bukit Beruang UTeM. Secondly, filtering West coca oil using this pump, which showing in the picture, with using filter paper size 47 mm. Then the pre-treatment filtering of West coca oil. This stage done by heating the 1 liter of filtering West coca oil onto 220 centigrade for 10 minutes. With 60 stir RPM. Then put 33 gram of ginger to reduce the FFA, which is free fatty acid, with the 3 mm thickness. Then turn off the hot plate and remove the ginger and leave it for 24 hours. After 24 hours, for that pre-treatment, should heating the West coca oil onto 50 centigrade with the stir 70 RPM and mixing 7.0092 mole of methanol and 2.25 gram of sodium hydroxide, which is NaOH. Then leave it for 24 hours, and this picture showing the result of this stage. Finally, this photo showing the result after washing process. Here is the FTIR test. FTIR test considered as one of the most important characterization tools, which created the spectrum of infrared observation of the chemical bonds and functional group. Both spectrums with the wavelength range of between 10,000 centimeter to 4,000 centimeter. Registered at 2 mm, scan speeds with a width of 7.1 mm. And here we have the compounding method and natural rubber formulation. There are various different formulations of natural rubber compound as shown in this table. Compounds were prepared in open to roll mixing mill as shown in this picture at 35 centigrade and a friction ratio of 1.3. The mixing period of the rubber formulations was about 20 minutes. And here is we have the cure characterization using the humidity. The vulcanization reaction has been tested from data obtained from an ODR, which is shown in this picture. And we have the performance testing, mechanical testing, tangential testing. The sheet thickness 2 mm was accomplished using a Walls DIE cutter by molding the compression into the dumbbell shape as shown in this picture also. Physical testing, hardness testing. Hardness implies the material's elasticity. The less hardness, the more porous the material is. And this picture showing the hardness meter. Thirdly, we have the result and discussion. Then we have the cure characteristic analysis. Higher cure rate for the oil-loaded samples as an advantage for higher production output, especially for the cooking oil types as shown in this table. And this data get from this picture. However, transesterified with cocoa oil shows a good plasticizing effect to facilitate mixing supported with lower compound viscosity. And here is we have the mechanical testing result. The plasticity effect for the cocoa oil decrease the modules but enhance the elongation aspect of the volcanizates. First picture showing the tangent strength. An additional hypothesis is that the significant reduction in tangent strength from transesterified with cocoa oil 10 gram to transesterified with cocoa oil 30 gram are due to the plasticizer interaction, which is more prevalent at higher transesterified with cocoa oil concentration and contributes to the large drops in tangent strength. And the second picture showing the elongation effect. Actually, the increase in transesterified with cocoa oil loading was attributable to the degrees stiffness associated with the high concentration of the plasticizer, which result in significant elongation at break when the load was increased. And this picture showing the Young's model 300 models transesterified with cocoa oil at 0 gram show the maximum value in Young's model, while the lowest value for Young models is transesterified with cocoa oil, which is 30 gram. There is a phrase known as anti-plasticization, which refers to the mechanical phenomenon defined by the increase in the stiffness of the rubber as a result of the inclusion of a tiny quantity of transesterified with cocoa oil. Then the second chart showing the tear strength. In terms of tear strength, transesterified with cocoa oil at 0 gram, which is a comparative formula that doesn't include synthetic rubber, has a number that is equivalent to transesterified with cocoa oil 5 gram, but it is lower than transesterified with cocoa oil 30 gram. It was the ratio of natural rubber to synthetic rubber that caused the difference in tear strength between each tear strength symbols. And here is the physical testing result, hardness analysis, and this is the table, and here is the chart. Hardness analysis average hardness value taken from 5 data for every sample degree in line with increasing diseases of the coconut oil. Finally, we have the FTIR spectroscopy analysis. The peak at 1448 centimeter has been attributed to deformation of methyl group CH, and it is associated with the transesterified with coca oil as well as the natural rubber chain structure. It is possible to symmetric vibration of methyl CH group in natural rubber are responsible for a band around 1371 centimeters. After careful analysis to overall experimental data finding, it can be concluded that raw material characterization such as hardness analysis and tangible properties was helpful to identify the behavior of raw material before conducting the experimental procedures. Using FTIR analysis, the presence of hydroxyl group in rubber compound was analyzed and confirmed using FTIR spectra. It can be proven that the different types of rubber compound proceeds distinct infrared spectra, which due to dissimilar bond stretching. However, the West coca oil was effectively used as a raw material in the production and characterization of sustainable rubber compound, which was generated via that transesterification process. And finally, we have the references part here. On the end, I would like to thank you for your attention. Bye bye.